For most of my adult life, every time the subject of getting off the grid came up, I got pointed in one direction: solar. Cover the roof, finance it over 20 years, buy a wall of lithium batteries that'll be dead before the loan is, and call yourself independent. I looked hard at that deal. It never sat right with me. So I went looking for the other answer, the one nobody seems to want to talk about. In this video, I'm going to walk you through 5 off-grid wind turbines a regular man can actually put on his own land, and I'm going to do it differently than the usual top 10 list. I'm not going to rank them 1 through 5 like it's a horse race. I'm going to lay them out by your situation, because the right turbine for a man on 40 acres in Kansas is the wrong turbine for a fellow on a half-acre lot with a homeowners association breathing down his neck. By the end, you'll know exactly which one fits your ground. But before any of that, you need to understand why this even works, because the first thing anybody told me was that home wind is a hobby for tinkerers. That's the line. And it's worth asking, who benefits from you believing it? A cubic yard of air, moving at 20 miles an hour, carries far more energy than the sunlight landing on a panel the same size. Wind isn't a flat sheet catching light. It's a 3-dimensional weight of moving force. And one modest turbine, grinding away through a dark winter storm, can outproduce a whole roof of solar over the same stretch. So why the push towards solar? Because a 300-foot tower owned by a utility makes money for the utility. A quiet machine on your own pole does not. There's no villain in a back room here. There's just a sales model, and folk wisdom doesn't have a marketing budget. All right, let's get to it. Start with the man who wants the whole thing done. You're not looking to trim the edges off your bill. You want to zero it out. You've got the open land and the wind to do it, and you'd rather spend real money once than keep renting your power forever. For you, it's the SD6, built by a company in Scotland. This is a 6-kilowatt machine, and what I respect about it is that it has almost no brain on purpose. Most modern turbines are packed with sensors, little motors to aim them, computerized brakes. Fine, until a circuit board cooks itself in the middle of a blizzard, and now you've got no power and a repair bill. The SD6 sits its blades downwind of the tower, so the wind itself drags it into position, like a weather vane. No motor, no chip to fail. And in a hard gale, where a normal turbine slams on the brakes and shuts down to keep from tearing itself apart, the SD6's blades physically twist and spill the extra force on their own, so it keeps making power right through the storm. It is not cheap, and I won't pretend otherwise. By the time you've stood up the tower and poured a proper concrete foundation, you're in the $25,000 to $35,000 range. But the 19-foot rotor puts out 10 to 14,000 kilowatt hours a year, and the average house burns about 10,600. One machine, bill gone. And with no fragile electronics, it's built to run 25 years on a yearly lookover and a bearing change every 5 to 7. It does its best work in winter, at night, in foul weather, which is exactly when your solar is asleep. Now the opposite, man. You've got the desire, but you've also got neighbors, a tidy lot, and an HOA that will lose its mind the day you try to raise a 60-foot mast. For decades, that was the wall that stopped home wind cold, because to reach clean, fast air, you needed height, and height meant a fight. The Tessup Atlas walks around that fight instead of through it. It's a vertical axis design, which means rather than a propeller swinging its whole body to chase the wind, it's a set of aluminum scoops looping around an upright shaft. It catches wind from any direction at once, which suits the messy, swirling air you get down low between houses and trees. And because it spins on a balanced vertical axis, all the force runs straight down through the center. No sway, no low hum traveling into your walls. None of the structural drama that makes a roof-mounted propeller a nightmare. You can bolt it to a beam or a short ground pole and be done. The core generator runs about $900. Full kits with the good babri and a controller land between $1,500 and $3,000. It starts turning around 9 miles an hour, and you can drop that to 7 with low wind blades. It turns a zoning problem into a non-issue. Then there's the man on a small footprint who still wants more than a trickle. Tight backyard, maybe a flat outbuilding roof, not much room to spread out. For you, the answer is Flower Turbines, out of the Netherlands and the States. They look like aluminum tulips, and the blades move slowly enough that there's no propeller whine, just a low hum that disappears into ordinary background noise. You can stand beside one and talk, They're built so birds see a solid shape and steer clear too. But the reason they earn their place is something counterintuitive. A normal turbine throws a wash of turbulent air behind it, so set two close together, and the second one chokes on the first one's mess. These do the reverse. Pack them close, and each one gains up to 20%, because the swirl off one actively drives the next. So a cluster of 3 or 4 in a small yard outperforms what the same patch of ground should give you. A 3-foot starter unit runs about $1,400. Rooftop residential models start around $4,500, and they begin generating in a breeze as gentle as 2 miles an hour. For a tight lot, that's how you squeeze real output out of almost nothing. Now the practical man who doesn't want a project. Maybe it's a cabin, a hunting camp, a backup for when the grid drops, and you want something you can wire in an afternoon without an electrician. That's the Primus Air series out of Colorado. It's rated at 400 watts, and I know that sounds small, but understand what a baseline load is. 400 watts running steady through a dark, windy night keeps a refrigerator cold, keeps your lights on, keeps your radio alive when the sun's been down for 14 hours. It was built for sailboats, which means it was made to survive salt, freezing wind, and constant vibration. Aircraft-grade aluminum body, carbon fiber blades that flex instead of snapping, and the only moving part on the whole machine is the rotor. Best of all, they built the charge control electronics right inside the unit. No cabinet of rectifiers and controllers bolted to your wall. You run 2 copper wires down the pole into your battery bank, and that's the install. The whole turbine runs $1,200 to $1,500. It starts at 7 miles an hour, and it'll give you 30 to 35 kilowatt hours a month in a steady 12-mile wind. Rugged, simple, and honest. And finally, the man living where the weather tries to kill equipment. The high plains, a mountain ridge, anywhere the wind doesn't blow so much as scream. Most turbines have a fragile ceiling, and a 100-mile-an-hour gust will simply destroy them. The ice wind, built where you'd expect from the name, is made to thrive in exactly that. It uses 2 blade systems in one. A scooped inner rotor that grabs torque and starts turning in almost no wind, wrapped by an outer aerodynamic set that takes over when things get fast. Together, they let it ride out winds up to 130 miles an hour without flexing or braking. It's sealed too. Where most windmills hang their generator and gears up in the air to take the full beating of freezing rain, the ice wind drops the generator to the base and encloses it. No exposed gears, no external wiring, nothing to ice over. The off-grid models run $3,200 to $4,500. It only makes 150 to 300 watts steady, so this isn't about volume. It's about the difference between something breaking and nothing breaking. Direct drive, no transmission, 25-year life, effectively no maintenance. You mount it and you forget it. So which of the 5 is right? Whichever one matches the situation you're standing in. But here's the thing I came away understanding, and it's bigger than any single machine. Wind is the partner solar always needed. In the dead of winter, when the sun sits low and your panels are weak and the days are short, the wind is at its strongest. They cover for each other. Add a Primus or a small cluster of flower turbines to an existing solar setup, and you can cut your expensive battery storage by as much as 40%. Because instead of hoarding power in lithium for a cloudy week, you let the wind work the night shift. One piece of advice before you spend $1, and almost everyone skips it. Do not guess your wind. Spend under $100 on a data logging anemometer, mount it up where the turbine would actually sit, and let it record for 6 months to a year. That gives you your real numbers, not a hope. If your average comes back under 8 or 9 miles an hour, wind may not be your main player, and it's better to learn that for $100 than for 30,000. But if the wind is there, the whole math of your independence shifts. Wind was the first free fuel men ever put to work. We crossed oceans on it and ground our grain with it, long before anyone sold us a meter. It never went anywhere. It's passing over your roof right now, free of charge. And the only thing that's changed is that somebody convinced a couple of generations to treat it as a nuisance instead of an inheritance. Wind is a strong answer, but it still asks for the right ground and the right wind speed, and it asks for patience. There's one more source that asks for none of that. It runs day and night, every season, and never stops. And if you've got so much as a steady trickle of moving water on your land, you can build it yourself for around $50. That's where we're going next.